Hello everyone, I'm back again. This is my second tutorial video, and I also request uh, the learner to subscribe my channel, and I'll teach you end to end from data science to AI. Okay, and I'll try my best to make my tutorial as simple as possible, so that learner can easily learn all the things, important things, and build their career. Okay, let's start. So today I will discuss about the Python library. Okay, but not all the libraries which are needed for data science. I, in this tutorial, I'll only discuss the two library. One is NumPy and another one is Pandas. Let's start. So what is NumPy? NumPy is actually numerical Python. This is the core numerical computing library in Python. Okay, so it's a very high performance multi-dimensional array object, and it works on only numerical values and do some mathematical calculation. Now, what is Pandas? It is also powerful data manipulation and analysis library built on top of NumPy, okay, but it's work on the relational or level data set. Okay, it's work on table-like data. So together, these two library form the absolute foundation of modern data science, machine learning, and AI ecosystem. Now, why is NumPy important? Very simple. It's a homogeneous data. It works on similar type of data set. Obviously, it should be numeric value, like it should be like int, float, like that. Okay, and all the as is homogeneous because all the element of the array should be similar type, same type, and this is the n-dimensional structure. It support n-dimensional structure. I mean 1D, 2D, 3D. Next one is the vectorization. Yeah, the interesting thing. Actually, support a vectorization and mathematical formula. Without using traditional loop, you can easily apply the mathematical vectorization rule, like summation of two array, multiplication of two array, okay, like this, and it's very fast, okay, because it's close to C language. Okay, now come to the pandas. Now, I said pandas is actually heterogeneous. I mean, it works on the data which have different type of data type, like numerical, string, boolean, datetime, etc. And it support the level access. Okay, it provides intuitive data aligned with explicit row indexes and column names. For example, there is CSV store. Actually, it contains the uh, record of the marks of each student of a class. Okay, or it's a name or column like name, student. I mean student name, student class. Okay, um, marks, grade, like that. And also is a high level abstraction. It's provides different function. Using those function, you can easily handle missing values of a CSV dataset, filtering rows, grouping data. Okay, and using the single line of code, you can do that. Now, comes the comparison NumPy versus Pandas. First is here NumPy works on numerical data and do some mathematical operations. Pandas is data manipulation and analysis purpose. NumPy support n-dimensional array. Here Pandas, series like a 1D series, data frame like table like data. Okay, usually 2D. Data type NumPy homogeneous, that means same data type. Pandas heterogeneous, mixed data type. NumPy, there is no concept of labeling, but Pandas label rows and explicit columns. Performance, obviously NumPy is a very fast because it's closer to C. Pandas slightly slower, obviously because it's Pandas built on top of NumPy. And primary use case like for NumPy is usually used for scientific equations, matrices. Okay, and Pandas, it works on real world messy tabular dataset. Now focus on the NumPy. Okay, so in NumPy, how we are creating arrays. Okay, here you can see in the left side window block, you can see first, you can see importing NumPy. This is a basic syntax of importing any library. Okay, and now we're creating 1D array. Here you can see variable arr equals to np.array. Using array function of the NumPy library, we can create array. And in the array method, we are passing the list. Okay, you can see it is simple list, Python list. Now this array method will convert this list into NumPy array object. Now here the below is a 2D array. Just I am passing the array a list of list. You can see this is a list and each element of the list is also a list. Okay, here how you can actually, this is a process of creating the two-dimensional array. And also you can in this way you can 3D array and more. And right side block you can see some special arrays, like if you want to create an array of zeros, ones. Okay, these are the methods, zeros, ones. Okay, you can see arrange. Actually arrange is usually creating the range of numbers and creating the array with the range of numbers. Like starting, this is the first parameter is we are passing the starting point, and the second parameter with the count of the element. So 0 to 4 is creating an array which contains 0 to 4 elements. And here you can see the line space function. Actually here creating the array, and where the difference between each element is space same, actually space, line space, equal spacing. So 0 and 1 is the lower bound and upper bound of the range of the number. In between we have to number should be, the element should be between 0 to 1, and number of element of the array should be 5, and it creates like this way: 0, then increment 0.25, then increment 0.25 and 0.25 and 0.25. So you can see the 5 element created. Okay, Now moving to the next, some operations. So you can see vectorized math operation. Yeah, this is a very interesting thing. Without using loop, how you can adding two arrays, okay, multiplicate two arrays, okay. This example, you can see the array A and array B, okay. Just write A plus B, it's automatically adds the element of the two array. Similar way, multiplication, okay. So without using any traditional loop, is in just one line you can do the operation, and it's very super, very fast. Now the data properties, how using the NumPy you can explore the data types and all. You can see this array.shape. It returns the number of elements and all. Okay, you can see it returns 6. I mean, because it contains 6 elements. Then end dim actually returns the dimensions of the array. It returns 1 because 1 dimension array. Now array.dtype actually returns the data type of the array. As the NumPy is a homogeneous, means contains the same type of element. That's why it's only one data type. That's interesting. Now another interesting method is reshape. Actually, using reshape, we can create uh, any dimension array. Like as our this array is a 1D array, right? Now we are creating 2D array from this array. Array dot reshape 2 and 3. 2 is the number of row and 3 is the number of columns. So here you can see it is a 2D array we have created from the 1D array. So understood. So move to the next. Yeah, another real life uh, kind of scenario, a real life use case you can say. You can see that is a array of marks. Okay, 5, 6, 7, 8, 90. If you want to find the average, just use the np.mean and pass the list array. Sorry, it will calculate average. If you want to know the highest marks, then just max. Sorry, and you need to pass the marks to return the maximum number. Similarly, you want to lowest, then mean. You want to sum of all the element, just use sum. And if you want to find the standard deviation, just std. Yeah. As in the past video tutorial, I've shown you that what is mean, mode, okay, standard deviation. So this is the Python NumPy function. You can calculate those things. Okay. Now going to the pandas tutorial. Pandas data is like this. The one data is 1D data. This is like data. Same like 1D array of the NumPy, but object is different. Okay. These are data frame. Right hand side you can see data. These are 2D data frame. Okay. I'll show you in the lab. I mean, I'll run the code for NumPy and pandas to show the how it looks. So actually, what pandas does, like loading the CSV file or any Excel file, exploration, view data in snippet, structures, metadata instantly. Selection, isolate specific column or rows for focus analysis like this. You can see in this df.pd reads CSV, it's reading the CSV file. Now exploring df, if I print df.head, it will print the first 5 rows of the data. Df.info, it will give the full summary, like how many rows, column, like this. Suppose you want to select simply any particular one column, okay, like this way you can see. Select df marks, reprint one column. You want to select multi-column like this. Suppose in the data set 10 or 20 columns were there. You want to print particular columns. So like this way you can do. Suppose you want to display the first row of the data set using this I lock. That you can just pass the index number 0. It will print the first row of the data set. So it's a very primary use case of the pandas. Also for advanced analysis like filtering data, okay, you can see df marks greater than 80, and it means it will print the select the student that marks is greater than 80. And if you want to add new column, you can add this way df result. Actually we are trying to add result column in the data set, result and pass. Actually here you can see first filtering the student uh, who got above 80% marks, and for those students actually set the result as a pass. Okay, handling missing data, yeah, you can do like this way. Data is null. Actually it will says you the is there any empty field or not. If you want to remove, then drop in. This will remove the particular row, or sorry, particular field which it has null or empty value. Okay, suppose you want to fill the empty field or null field with some value, you can do this, fill in a replace with null with 0. Okay, this is a group by and aggregation function. Group by, like this way you can use group by. Here it's actually average marks by name. Okay, these are the advanced use case of the pandas. So if you have any question related to NumPy and Pandas, you can post in my channel, and I'll try to answer in the next recording or also in the um, comment as well. And before ending this tutorial, I want to show you the lab. Okay, and to run some code to show you the how NumPy and Pandas works. Just give me a moment. It is loading the files. It will take couple of minutes. Yeah, almost loaded. Wait for still processing. We have to wait until it finishes the process. Otherwise, it will not be able to run the code. Meanwhile, I can show you the data set, sample data set, on which we will show you the demo. Okay, here you can see in my example script we have used sample data.csv. Let me open this data. Sorry. The sample data. Let me open. Yeah, these are sample data that you can see. Name, age, marks. Okay, for actually the demo data. Name A, B, C, D. Age is tag like that, and marks is this. So I will work on this data. Okay. Some problem with loading because I cannot see the run icon of in the editor. Give it. So here you can see this. Meanwhile, we can just try to explain this code here in this two line. Actually, importing the pandas and NumPy library. Pandas as PD and NumPy as NP. Now here using the pandas, we are loading the data as a data frame. Okay, actually pandas load the data as a data frame. Okay, now it will print the data. You can see df. Here it will show the shape, print the shape of the data. Also it will print the columns of the data, depending on the name of the column names it will return. Here you can see selecting the marks column from data set, and here you can see it transforming the marks column to NumPy array, as we are passing the marks value, list of values to array NumPy array, and it gives a marks array, the NumPy array. I think loaded. Let me first need to run this one. Is importing the library. Actually, this editor is Jupyter notebook file. Okay. Actually, Jupyter notebook is very easy to showing any demo. Okay, for demo purpose, practice purpose. Jupyter notebook is very easy. Okay. And inline you can see the output as well. So it's okay. It's done. Now running the next block, code block. It's okay mean that's it. It's loaded into df. Now let's print the data. Yeah, you can see name abcd and I correctly print. Okay. Now it will print the shape and columns. Yeah, shape is 4 3. 4 3 means 4 is number of rows and 3 is the number of column. Column is 1 2 3 and 4 is row is 0 to 3 and 4. And df column print the all the column names. You can see name, age, marks. This 3 column present in data set, and all the type is string. Str is means string. Fine. Now nothing to print here, just actually capturing the marks from the data set and in creating the NumPy array. Here it will, NumPy operation will happen. Like you can see now it's calculated np.mean marks array. Now it will calculate the average value of the from the marks array. It's been the 81.25, then max, mean, standard deviation. You can see all these values showing. These are NumPy operations. Okay. Now back to pandas. First, let me run the What is doing? Actually, it's filtering data like whose marks greater than 80, greater than 80. Student marks greater than 80 is only painting the two row. You can see marks is 1985. B and C student. If I go there, B and C, yeah, these two students. Correct. Now the last box. Now adding the new column. Okay, this is a column like pass. Okay, so now sorting the data frame based on the marks, ascending order. Okay, array sorted, and we already have added the result as well in the data set, and finally pin the new data set. You can see data sorted and also result column added with the value pass. So these are the very basic operations of NumPy and Pandas. So for now I'm closing this tutorial, and if you have any question, please pass in the comment. I'll try to explain in the next session. And don't forget to subscribe my channel. I'll every week I'll publish at least two three videos regarding data science step by step. My aim is to make you zero to hero in AI, from data science to AI. Okay, thank you.